Hello everyone, welcome to my YouTube channel. Today we are going to learn about 0 or 1 knapsack problem, one of the most famous optimization problems in computer science. We will see the pseudo-algorithm, an example, and then we will write the algorithm together in Python. The knapsack problem shows up anytime we want to make the best choice under limited resources. Think of it like putting items in a box. Each item has a value and a weight. The box can only hold limited amount, so we can't take everything. Our goal is to pick the combination of items that gives us the maximum total value without going over the weight limit. This simple idea is used in lots of real-world situations, such as budgeting money, scheduling tasks, resource allocation in operating systems, or even portfolio optimization in finance. In the 0 or 1 knapsack problem, we are given a set of items. Each item has a profit or value and a weight. We have a knapsack with a maximum capacity. So in the question or in the scenario, we will have a maximum capacity. It will be given. And we need to select a subset of items. Let's say we say X, Y, Z, and so on. And the goal is to select the subset of the items to maximize total profit without exceeding the capacity. By the way, the 0 or 1 part means that we either take an item or leave it. So we can't take fractions. There is also fractional knapsack problem, which we will see in upcoming lessons, but for now we are assuming that we can either take the whole item or leave it. Let's see an example. Let's say our box has a capacity of 48 kilogram. And let's say we have two possible items. Let's write it here. Or items. They have values and weights. Let's say X and Y. And the value of X, let's say 15. The weight can be like 41, and for the Y the value can be 25 and the weight can be 30 kilogram. So now we can select the best one, right? Because we have only two possible items, so we can directly select the best one. However, what happens if we have hundreds of items? Each has different weights and values. Then this is literally impossible to look each different combinations by hand. So instead we use dynamic programming. Dynamic programming breaks the problem into smaller subproblems and stores the answers in a table. It is basically trying each smaller capacities to see which combinations of items are the best in those small cases to get the real answer at the end. So first it is starting the smaller capacities and it is looking at which items we can take in order to fill these capacities, because if the capacity is small, then we can decide much more easily since we have limited options, right? And then gradually it is reaching the real solution, the real answer. And it is creating a table to hold different combinations, as we can see here. In this table, the columns of the table represents capacities from 0 up to the maximum weight. As you remember, in our example, we said that the capacity is given as 48 kilograms. So that's why we write here from 0 to 48 kilogram. The 48 is the actual capacity given in the problem. If the capacity is 3, let's say, if they say that the capacity is 3, then we will write 0, 1, 2, 3 for our columns. If it is 5, then we will write 0, 1, 2, 3, 4, and 5, right? But for our example, it was 48, so we wrote all possible capacities from 0 to 48 kilograms. And the rows represent the items. one by one. So if the items are X and Y, then our rows will be X and Y, basically. Let's write them. However, the first row is an exception. It is there to indicate 0 items here, which means what happens if we pick no items? Okay, what happens? If we pick no items, we won't get any value, no matter what the current capacity is, right? So that's why we are filling this row with all zeros. So, if we have two real items, X and Y, then there will be 3 rows in total with the 0 item row. And each cell in the table tells us the best profit we can achieve with that many items and that much of capacity. For instance, for the item X, if we assume we have 25 kilograms capacity, so we are here, and if the weight of X is less than this capacity, so let's say the X weight is 10 kilogram, then the value of X, let's say A. However, if the weight of X is greater than the current capacity, which is 25, then it means that we are not able to take X, which means we will directly take the value of that capacity in the previous row, which is 0. Then after completing the whole row for X, we are basically filling all of them, we are moving to another row which stands for another item called Y. And again, we are doing the same thing. In order to do that, for each capacities, we will look the previous rows to decide on whether taking Y is a good choice or not. If it is a good choice, we will add it. And by filling this table step by step, we can exactly see how the solution is built. And at the end of the day, the bottom right cell here, let's say it will be Z, it gives us the maximum achievable profit. So it will be our last answer. And the nice thing about the table is that it doesn't just give us the profit. We can also trace back through it after we complete it to figure out which items were chosen. And we will also look at it both in our example and also in coding, so don't worry. During this video, first I will explain the algorithm and let you understand how it is solving this problem by solving it step by step. I will also give an example. We will understand it with an example much more easier. Then in the next video, we will write a code in Python. So let's start writing our pseudo-algorithm. The first thing we should do is, let's write it like that. The first step, we will create a table. And let's call it DB. And DB will have rows, number of rows, which will from 0 to n. As you remember, the rows represent the items itself. And it will also have columns from 0 to the actual capacity. Then in the second step, I will create a loop. As you remember, we fill the first row with zeros, right? Because it is an initiation step for our algorithm, which represents 0 item. So, in order to do that, I am creating a for loop for W from 0 to C. Here the W represents the current capacity from 0 to C. What will I do? I will say put 0 there. Since it is the first row, we are writing 0 for that specific capacity. So we are filling all the columns with zeros for the first row. Then I am creating another loop. In this loop, I will walk through each item. I am saying for I from 1 to n, why we said 1? Because as you remember, the position 0 represents the initiation step, and we have already filled it here. So we will only look the item from the first position up to the last one. Inside of this for loop, I am creating another loop because for each row, I should walk through each capacity from 0 up to C. W from 0 to C. Okay, for each capacity from 0 to C, we make a decision. Should we take this item or not? I am checking if Wi is greater than the current available capacity. By the way, I forgot to write the parameters here. So the parameters are the weights and profits. Okay. If the item is too heavy for the current capacity W, we cannot include it, right? So we just copy the value from the row above, as we did here. If the weight of X is greater than 25, then we are directly copying the previous row's value. So that means the best profit is the same as if this item didn't exist actually. So the ith position, the ith row, and the column W will be equal to the previous row in the same column. Exactly. However, if the weight of the current item is less than or equal to the current capacity, we can say else here. So that means that the item fits. The item can fit into the box or bag, whatever. In this case, we have two options. We can take this item. However, we will take this item if it is profitable, right? If it is not a logical decision, then we don't want to take it. Or we can take it and we add this item's profit to the best solution for the remaining capacity. So actually what we will do is we will take the maximum let's write it first. The previous row value is dp. Let's write it in different colors so that we can understand it better. This is the previous row in the same capacity. And we are taking the row, the previous row, or we add the profit of this item to the best solution for the remaining capacity, basically. By the way, this part is very important here, and while solving the question, we will see how it is revolving. So don't worry if you don't understand it right now. And at the end of the day, we are returning the last column of the last item. The last item is n, because n is the number of items. And the last column is c. So we will actually return this. Let's say return here. So the answer will be in this position at the end. It represents using all n items and the full capacity C. So as I said before, if you didn't understand, don't worry, you will understand everything while we solve our problem. So this is the pseudo-algorithm of Knapsack 0 or 1 problem. Now we will move with a simple example, and then we will see a complex example to understand it better. We will solve it by hand to understand the algorithm in each step clearly. Especially this part here is I think it is the most complex part in the algorithm. And then in the upcoming video, we will write a code in Python to implement this algorithm. And we will see how it is working. We will check it with different scenarios and see, is it really working actually? So let's move with an example then.